In this session we are designing programmable timer using CD4541 or MC14541 IC. It is frequency divider, it is delay time generator, it is programmable timer IC. I will explain each and every step. What are the function of the pins? We will see it in detail. Anytime we will press the reset button, the IC will go in reset mode. Output will disable and it will start counting from 0 line. Let's design this circuit. We will divide the frequency using these binary inputs. Input frequency will be divided by these numbers by selecting these binary inputs. If we will provide 1 Hz frequency at input, this IC will provide output after 18 hours. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. It is 4541 from Motorola. There are many manufacturers for this IC. Basically it is programmable timer. It will use just only 2 resistors, 1 capacitor. We can program its oscillator frequency and then it will divide that frequency using its internal binary counters. And we can take flexible output. Let's see its each and every parameter. We will see it theoretically and we will make it practically. And I will try my best to explain every function to take useful benefit from this IC. It is CMOS family from CD4000 series. 14 pins. Very simple and easy to use and extremely precise IC. We can design a circuit to a one-time delay or repeated delays at a specific frequency timing which we will select from its control pins. Index mark here. If we place this IC in this way, index mark here, pin 1, pin 2, pin 3. These are programming pins. Here is pin number 14. That is VCC. 3 volt to 18 volt. I will use 12 volt. Pin 7. VSS. Ground. This is positive rail. We will connect pin number 14 to positive supply. And here is negative rail. We will connect pin number 7 to negative side to this rail. Pin 4 not connected. Pin 5, pin 6. Pin 5 auto reset. Pin 6 master reset. Pin 1 is named RTC. Pin 2 CTC. Timing resistor, timing capacitor and RS. 3 components to create its internal oscillator. Any frequency we will calculate here that will be applied to its internal circuit. After processing through these control inputs, it will provide output at pin number 8. We will select default division number using pin number 13 and pin number 12. These are named A and B inputs. Pin 12 is A, pin 13 is B. These are binary selectable inputs. Pin number 11 is not connected. So this pin not connected, this pin not connected. Then here is pin number 10, here is pin number 9. Pin number 10 is mod. Pin number 9 is output select, Q or Q bar. Now we will study each and every pin and we will design it. If you are new to my channel, I will invite you to subscribe my channel and I will also invite you to join my channel if you want to support my channel. These are frequency components. We will calculate frequency F oscillator 1/2.3 RTC, CTC. 2.3, it is constant for its oscillator, RTC and CTC, timing resistor and timing capacitor. We can adjust resistor as per our requirement, but for capacitors it is very hard to take exact values. So it is the best to select a fixed capacitor and then we will select the resistor value. Capacitor, we will select approximate value 10 nanofarad. We want to know RTC, resistor, timing resistor. RTC will 1 over 2.3. Let's suppose I want to design this circuit as 1500 Hz oscillator frequency. This is our required frequency. If you want to design at low frequency, then you will need to select high value capacitor because it is inversely proportional. We can select DC, that means low level frequency to 100 kHz. This is allowed range to design its oscillator. In this case, 1 divided by 2.3 multiply 1500 multiply with 10 raised power minus 9, 10 nanofarad. Required resistor 28985 ohms, that is around 29 kilo ohm. If I need exactly this frequency, then I will need this resistor 28k, 29k, or we will use any closer value 28k resistor with some preset, and it is best to select minimum tolerance. Let's suppose 1% tolerance, that will good. Capacitor must be with lowest tolerance to take exact fixed frequency. But this time I will select 33 kilo ohm. 10 nanofarad 103 code. So I will use 10 nanofarad capacitor. It is also commercial, it is not precise value capacitor. Now we will calculate approximately the output frequency 1 over 2.3 multiply with 33,000. Let's check it practically. It is 32.79 kilo ohm. 32970 ohms, and this is 10 nanofarad capacitor. Output frequency will around 1318 Hz. Because the resistor value is now increased. We calculated 28k, but available resistor is this. If I will use exactly this, the frequency will 1500 Hz. Same way, its capacitor value will deviate, the frequency will shift. RTC 33 kilo ohm. CTC timing capacitor 10 nanofarad, and we will connect RS. Minimum value for RS is 10 kilo ohm. If we select any other value, that time we will select 10k, but for higher frequencies we will select RS is equal to 2 RTC, twice to the timing resistor, this one. So we will use 66 kilo ohm. Pin number 2, capacitor. Resistor at pin number 1. Capacitor at pin number 2. Second side of the capacitor is connected at open point, that is not connected to IC. And we connected resistor at pin number 1, 33k. With 33k, the same point, we connected another resistor 33k plus 33k to pin number 3. Then there is pin number 5, that is auto reset pin. Pin number 5, auto reset. If it is connected to 0 to the ground side, auto reset will start. What is auto reset? When we will connect this IC to power supply, its internal counters will reset automatically and this IC will start functioning. All outputs from the all counter stages will start and IC will start from 0. Auto reset on. If we will connect to supply pin, logic high, positive rail, that time auto reset will disabled. So it is power on reset. We will connect to low side. Just we will plug in, this IC will start functioning. Pin number 6 is master reset. To operate this IC, this pin must be connected to low side, pulled down, so timer will work. Timer on. Anytime we will turn it to high, all outputs, all counters will go to low. Timer reset. If it is pulled on to high side, this IC will not functioning until this pin will return back to common side, ground side. Pin number 5 we will connect to ground. Pin number 6 we will create a reset circuit. We will connect here positive voltage. We will connect a push button, 10K resistor, resistor second side ground. This point will be connected to pin number 6. Anytime when it is counting during operation, we will press this button, this counter will start from 0 side. So this is function of pin number 6. Pin 7 we discussed, it is ground. Pin number 8 output. If we are designing any relay circuit, either we are turning on any relay, any MOSFET, whatsoever, to take its useful function, this output pin is used. To check its function, I will connect resistor, LED, ground. It is 1 kilo ohm resistor because we are using 12 volt power supply. So pin number 8 is output. Pin number 9, that is output selection, QQ bar selection. If pin number 9 is connected to low side at logic low, its output will normally low. When we will press reset button, all counters will reset and output stage will also low at logic low. Then after operation, after counting number of pulses, let's suppose I selected this IC to operate at 256 numbers. After 256 pulses, its output will high. If I will select pin number 9 to high, when we will reset this IC, all counters will go, but output will be inverted. We will take logic 1. After 256 pulses, its output will low. Here it was rising up, here it is falling down. Then after 256 pulses, low, then high, and here opposite. So output level will be shifted by selection of this pin number 9. Let's connect this LED that we discussed here. LED low side, cathode side to ground. Pin number 8, 1K resistor, the same 1K resistor, anode, cathode of LED is grounded. We will connect pin number 9 to low side. Now when we will press reset button, output will low and then output will appear at high side. Then there is pin number 10. Pin number 10 is mode selection. If you want to make delay timer, Just only we press reset button, this IC will start to count. After number of pulses which we will select from these two pins, it will create a delay time, then it will operate the device for that duration, then it will turn off. So it is single cycle. If connected to 0, single cycle operation. That means after resetting this IC, output will low. If we will select pin number 9 to low, then it will high. So it is one cycle. After that, this IC will not work. So just only one cycle, one delay time will be created. If we will connect pin number 10 to high, this IC will start counting after number of pulses. It will repeat. So it is recycle mode. If we want to divide any high frequency to low frequency, we will select pin number 10 to high, so it will work in recycle mode. If we will select to 0, just only one reset, it will create one delay time to turn on or turn off any device depending on the connections, then it will stop working. But here it will auto reset and it will count the frequency and it will divide the frequency by that number of pulses which we counted from here. Then pin number 11, not connected. 12 and 13, these are two binary inputs. Pin number 12 A, pin number 13 B. A, B, A is 12, 13 is B. How many counter stages within this IC we will use to count? Let's suppose we will select 0, 0. If we connect both pins to ground side to low side, counter stage, 13 stages will be counted. Output 2n. This method will be used. It will divide frequency 8192. That means if we provide 1 Hz frequency at pin number 3, yes, one other thing. If we don't want to use these components, we will use external signal to connect at pin number 3. In that condition, we will not use these 3 components. Just only any external signal will be connected at pin number 3. That will be divided by this number when these two pins are connected to low. If we connect 1 Hz frequency, it will provide output after these number of pulses. Let's suppose 8192 pulses means 1 Hz frequency. That means after 8192 Hz or 8192 seconds, because 1 Hz means 1 cycle per second. Now we will calculate the time divided by 60, 136 minutes divided by 60, 2.27 hours. Let's consider the minutes. If we will inject 1 Hz frequency at pin number 3, or we create a timer for 1 Hz, after this time we will take output. It will maintain output for this time 136 minutes, then it will turn off. If frequency will increase, let's suppose I provide 1318 Hz divided by 8192, 0.16 Hz frequency will be in the output. If we will connect pin number 12 to low, pin number 13 to high, that time it will use 10 stages. In that condition 1024 pulses will be used to trigger the output. 10, pin number 12 is high, pin number 13 is low, that time 8 counter will be used. 256 pulses. If you provide 1318 pulses divided with 256, so output frequency will 5.1 Hz. We injected frequency 1318 Hz, or if we provide 256 Hz, after 256 pulses in 1 second, output will appear. That means if we inject 256 Hz, the output frequency will 1 Hz, because it is dividing input frequency with this number, which we selected by this combination 1 0. If you connect both inputs to high, in that situation it will utilize 16 stages and 65536. After these number of pulses, the output will appear at the output. Let's make connections. Pin 9 is connected to low side, initial output low, mod selection. Pin number 10 will be connected to high. Here is pin number 10 will be connected to high, 11 not connected, 12. First we will connect pin number 12 to high, and we will connect pin number 13 to low. I will use 12 volt power supply. Capacitor at pin number 2, a resistor RTC 33 kilo ohm resistor at pin number 1 connected to open end of the capacitor. With open end of the capacitor, this 33K resistor that is connected in series with another 33K that is connected to pin number 3. Pin number 4 not connected, pin number 5 connected to ground, that is auto reset. One side of the switch is connected to 10 kilo ohm resistor. Resistor second side grounded. The same point will be connected to pin number 6, that is common point for resistor and this switch. Pin number 6, master reset. Anytime we will press this button, this IC will go in reset. Switch second side is connected to high, positive voltage. Pin number 7 grounded. Pin number 8 resistor. Resistor second side anode, cathode is grounded. Pin number 9 is low, to take normally low output. When we will press reset, all counters will reset and output will go low. Pin number 10 will be connected to high, to recycle mode. Pin number 10 is high, pin number 11 not connected, 12 high, to take this frequency. Pin number 13 low, 14 positive power supply. First we will check oscillator frequency, which we calculated. Yes, great. It's working nice. Now I will connect to pin number 2 to see the pulses. We have 1344 Hz frequency at pin number 2. And if you will check output, Hz at oscillator, 5.26 Hz. Input frequency 1318 344 divided with 256, exactly 5.25. That is output frequency. Now if I will connect pin number 12 low, pin number 13 high, this is pin number 13 high, pin number 12 low, (1344) divided with 1024, that we calculated from here. Now pin number 12 is low, pin number 13 is high. It is dividing input frequency with this number 1024, exactly 1.3 Hertz, 1.3 Hertz. Perfect. And we can see the output pulses are now different than the previous one. Now if both binary inputs are high, the IC will provide long duration. Still it is high. We can see it is creating a very long duration pulses. If we will provide 1 Hertz frequency at input, it will provide output after 65536 seconds divided by 60 and again 60 to convert hours. After 18 hours it will provide output. If you will provide 1 Hertz frequency at input, this IC will provide output after 18 hours. This time we are providing 1.3 kilohertz frequency, so we are taking this output. So this is amazing timer. This IC is available with different numbers from Motorolla, MC14541B. From Texas, the number will be CD4541. RCA Harris Rensas CD4541, Stmicroelectronics HCF4541, NXP Philips HEF4541, Toshiba TC4541, Fairchild on semiconductor MM74. It is TTL family, but in TTL family there is CMOS IC, that is 74C, that is indicating CMOS 4541. These are same, these are exactly equivalent to each other, but intercell ICM7241, same function, but pins are not compatible to this one. If you want to use this IC for this function, that time we will cross match the pins. So this is the function of this timer. If both pins are connected to low, the output frequency will be determined by this number. Pin number 12 low, pin number 13 high, pin number 13 high, we are dividing with 1024. If pin 12 is high, pin 13 is low, 13 low, 12 high, the output frequency is divided with this number. What is your opinion about this IC? If you experienced it, or if you know about this IC, and what is your feedback about this video? I will invite you to write your valuable opinion in the comments. If you have any idea to make delay timer, to create a frequency divider, and what are the possible ideas to utilize this IC, I will invite you to write in the comments. If this video is informative, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.